for example, an ionic hydroxide is when it's behaved like it's like an ionic compound. So if we have our NaOH aqueous, it will dissociate into Na plus and OH minus. A weak base does not dissociate 100%. And only a small percentage of the base forms ions in solution. So all of these weak bases are the ones that you have to react with water to make the OH. They're all the other ones that don't have that OH in it that you can be like, okay, yeah, that's base. It's everything else. Okay? So you should think to yourself, okay, well, it needs that extra bit of help, so it's a bit weaker. So the NH3, ammonia, if it reacts with water, we get our NH4 and our OH minus. Now again, look at, we are using the equilibrium arrows for our weak bases to represent that not everything on the reactant side becomes the product. Acids that have only one, okay, so this is now like a kind of another topic. This is the monopoly, monopoly thing, okay? So we just did strong, weak. Now we're doing the monopoly side of the lesson. Now, we already have talked about this a little bit, but this is kind of your formal notes on it, okay? Acids that have only one hydrogen atom per molecule that can ionize, right? Because some can't, like CH3, COOH, only this one will ionize, even though it has other H's in it, right? So it only has one H that can ionize. These are called monoprotic acids, okay? So the part mono means one. Protic, think of it as like proton. Remember how I keep saying, think of your hydrogens almost like protons, okay? Because a hydrogen charge, hydrogen plus one, means it only has a proton and a neutron, okay? So think about it like, so it's monoprotic, one proton. See? Yeah? Uh-huh. Okay. So like HCl, HF, HNO3, acetic acid, monoprotic acids can be strong or weak. How many H's it has doesn't influence its strength, right? Because like hydrochloric acid, that's super strong, but so acetic acid only is monoprotic too, but it's really weak. So that doesn't determine if it's weak or strong. Acids that contain two or more hydrogen atoms that can ionize are called, what do you think? Yes. Polyprotic acids. You guys are brilliant. So we kind of did these ones a little bit. I told you a little bit about them. So like our H2SO4, H3PO4. Okay? So they came from ions that had more than one charge. Another one would be like, okay, so acids with 2 hydrogens are specifically, they're polyproduct, but we can say that they are diproduct specifically. It's like saying there's multiple apples and this one is just manufactured. 2 hydrogens are diproduct, with 3 hydrogens are triproduct. Both are still called polyproduct though. It's just a type of polyproduct. When polyproduct acids ionize, only one hydrogen is removed at a time, with each acid becoming progressively weaker. So like we have our H2SO4 with H2O, makes H3O plus and HSO4 minus. Now, as we've discussed before, you can now take that HSO4, react it with water, but now, because you're smarter, you use the equilibrium arrows. Because now you know specifically that that is a weak acid. Now I'm going to show you something. Did you finish it yet? So look at your chart. What did we start with? We started with H2SO4. Well, that's in this category, sulfuric acid. So that's why I could draw one arrow over, because it was in the category of the 6 strong acids. But now go down your list, look down here, and look at third from that, that gray line is HSO4 minus. See that? So it's actually an acid. So it's like classified as a separate acid, but it's lower on the list, so that means it's weaker. And so I write it with my equilibrium, okay? And then look at what it actually shows you on the other column. It shows you SO4 minus. That says it's its conjugate base. Okay, this is the acid formula with its conjugate base. Now that's a chemistry 30 term. You don't need to know too much about it, but it's just interesting to observe. That's the other ion it goes with, right? This acid will produce this conjugate base. That's how we say it, okay? Yeah? So again, you don't need to know that column, so well for Chem 20, but if you start to see patterns, that's not a coincidence, okay? If you start to notice some of those patterns, then we're going to revisit this again in Chem 30 and go into more detail with it, which is actually really fun. Chem 30 is so much fun. It's going to be a good time. I'm so excited. Chem 30 and Bio 30, they're the best you'll ever take from K to 12. Okay. Physics. We'll do physics too. Okay? Okay. So now our bases. So our bases, our rule was if you can see the OH in the formula, it's strong. Okay. Now, with our bases that react with water in only one step to form hydroxide ions, are called monoprotic bases. Who would have thunk it? So, like sodium hydroxide. Bases that react with water in 2 or more steps are called polyprotic bases. Like a carbonate ion or a phosphate ion. So any base compound that comes with a polyatomic that has more than one charge, or just an ion with more than one charge. Now, as with polyprotic acids, only one hydroxide ion is formed at a time, and each new base is weaker than the last. So, if you took your carbonate ion, like from your dissociated original ionic compound, you react it with water, why is there no arrow? There we go. I'm going to use my equilibrium arrows because this does not have an OH in it, so I know it's not a strong base. So I make my hydrogen carbonate ion, that can react again with water to make OH minus, etc. Now, you might be observing that when you keep doing the reactions, you actually make an acid, or a conjugate acid it would be called. So this is a base, and this is its conjugate acid. Now, look at your diagram, or your chart again. Now, look at the very bottom right-hand corner of conjugate base. So we're going to look in the conjugate base column. What's the very bottom conjugate base? What does it have there? OH minus. So it's kind of like the opposite. Up here is the strongest acid. Down here is the strongest base. Now, as you go up this column, we have it goes weaker bases. Okay? Now, whether or not it goes one way or the other, we do that in Chem 30. Okay? So you don't have to be able to determine which way it goes until Chem 30. Okay? So just, start to look at those patterns, though, in here. It's kind of cool. So this can go 2 times. So you go as many times as you can. If you're told this is a base, X is a base, you react it with water as many times as you can to make OH, and then stop. So now, neutralization, last kind of topic here. And we've talked about this a little bit already too.